Here's lesson 3-4, parallel and perpendicular lines. You're going to learn some theorems about the relationship between perpendicular lines and parallel lines and transversals. In this video, just pause it whenever you feel like it. If you want to answer the questions first, go ahead and pause it. Otherwise, the video will just run straight through. So here's the review. A transversal always intersects at least two lines. A transversal never intersects two lines at more than 2 points. A transversal sometimes intersects two parallel lines. And a transversal always forms angles with two other lines. The theorems that you're going to use in this lesson have to do with the transitive property. And so here's a review of the transitive property. If A is greater than B and B is greater than C, then A is greater than C. If Joe is younger than Ann and Ann is younger than Sam, then Joe is younger than Sam. If you travel from station 2 to station 3, and you travel from station 3 to station 4, then you travel from station 2 to station 4. All right. Theorem 3.7, the transitive property of parallel lines, and Theorem 3.8. Theorem 3.7, transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So if A is parallel to B and B is parallel to C, then A is parallel to C. And in plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if M is perpendicular to T and N is perpendicular to T, then M is parallel to N. In this one, we kind of have two perpendicular lines equal one set of parallel lines. All right. This isn't in your packet, but here's a flow proof of Theorem 3.8, that if you have two lines that are perpendicular to the same line, then they're parallel. All right, so if we're given that R is perpendicular to T and S is perpendicular to T, and we're going to label the diagram to show some angles. So by definition of perpendicular, we have the measure of angle 1 equals 90, and the measure of angle 2 is equal to 90. And that's definition of perpendicular lines. And then, by the transitive property of equality, we have the measure of angle 1 is equal to the measure of angle 2. And so we have angle 1 is congruent to angle 2. That's the definition of congruent. And since angle 1 is congruent to angle 2, and they are corresponding angles, we have R is parallel to S, and that is by the converse of the corresponding angles postulate. All right, now, in this diagram, we want to know what the relationship is between segments AB and CD. All right. So we have, as you can see from the diagram, we have angle ABD and angle DBC form the angle ABC. So the measure of angle ABC is equal to 68 plus 22, which is 90. And that's using the angle addition postulate. We also have angle DCA plus angle ACB is equal to angle DCB. So the measure of angle DCB is equal to 55 plus 35, which is equal to 90. And since those angles are equal to 90 degrees, that means that AB is perpendicular to BC, and BC is perpendicular to CD. And so segment AB is parallel to segment CB by theorem 3.8, which says that if one line is perpendicular to a line and another line is perpendicular to that same line, then the two lines are parallel to each other. I think we're going to nickname this the perpendicular times 2 equals parallel theorem. Maybe that'll be easier to remember. All right. So if you look at this picture, we want to know if we can assemble the piece right to form a picture frame with opposite sides parallel. So if to make the picture frame, you will glue two different angles together. The angles at each connecting end measure 30 degrees and 60 degrees. When the pieces are glued together, each angle of the frame will measure 90 degrees. So the flow chart shows that the top and bottom pieces will be perpendicular to the side pieces. The left piece will be parallel to the right piece. The top piece will be parallel to the bottom piece. And so the opposite sides are parallel to each other. So, yes, I can assemble the pieces to form a picture frame with opposite sides parallel. All right, theorem 3.9, the perpendicular transversal theorem, says in a plane if the line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So we're going to place a right angle symbol in the diagram to illustrate theorem 3.9. So we should put a right angle symbol right there. If we look at diagram in number 15 here, A is parallel to G. and A is perpendicular to T, so G, according to this theorem, must be perpendicular to T. And in number 16, if we look at the diagram, we see that C is perpendicular to N, and N is perpendicular to P, or N is parallel to P. So that means that C must be perpendicular to P. All right. Now, to prove a relationship between two lines, in a plane, if C is perpendicular to B, and B is perpendicular to D, and D is perpendicular to A, we want to prove that C is parallel to D. To prove that, I think we can just use two parts of it given. And we'll use a flow chart. So we're given that C is perpendicular to B, and we're given that B is perpendicular to D. So that's enough information. Since B is perpendicular to both C and D, that means that C is parallel to D, and that's by theorem 3.8. If two lines are perpendicular to the same line, then they are parallel to each other. Here we have the same diagram again. Here, though, we want to conclude, see if we can conclude that A is parallel to B. The lines perpendicular to A are, the line perpendicular to A is D, given, and the lines that are perpendicular to B are C and D. Lines that are perpendicular to the same line are parallel. So we can, yes, we can conclude A is parallel to B, since A is perpendicular to D and B is perpendicular to D by theorem 3.8. Let's call it again perpendicular times 2 equals parallel theorem. All right, lesson check. In one town, Avenue A is parallel to Avenue B. Avenue A is also perpendicular to Main Street. How are Avenue B and Main Street related? Explain. So if we label the streets in diagram A for Avenue A, B for Avenue B, and M for Main Street, we would get a diagram that looks like this. All right. The perpendicular transversal theorem states that in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So Avenue A, Avenue B and Main Street are